Welcome to the Explainer. Right now, as you're sitting here, you are under constant attack from a whole universe of microscopic invaders. And yet, most of the time, you don't notice a thing. And that's all thanks to this silent, incredibly fast army that's working 24/7 to keep you alive. It's an ancient defense system, hardwired right into your very being. Today, we're going to open the gates and get to know your body's first responders, the innate immune system.
All right, so let's just dive right in. Picture this. You get a tiny splinter. Seems like no big deal, right? But with that splinter, just one single bacterium manages to sneak past your skin, which is our first big wall, and it gets into your tissue. So what happens then?
Okay, so if that one little guy was just left to its own devices, completely unchecked, it would start doubling and doubling every 30 minutes. In just 24 hours, you're looking at 100 trillion bacteria. To put that in perspective, that's enough gunk to fill over 25 gallons. Your entire body only has about 1.5 gallons of blood. So yeah, this is exactly why our defenses can't just be strong. They have to be ridiculously fast and just relentless.
So get this. Before even one of your immune cells has a clue that anything is wrong, the first alarm is already blaring. And the first responder? It's not a cell at all. It's actually a swarm of proteins that are just always there, circulating in your blood, in your tissues. This is what we call the complement system. Think of it like this ancient hardwired security network.
So these proteins, they're mostly cranked out by your liver, and they're just hanging out in your blood at all times, in really high numbers. They're ready to go from the second you're born. And they have a few jobs. 1, blow up invaders directly. 2, slap a kick-me sign on them so other cells can find them and eat them. And 3, sound the alarm to call in the big guns. The system is just designed to go after any surface that isn't protected. Its default setting is basically attack. So how does this thing get switched on? Well, it's got 2 main ways of doing it. The first one is called the alternative pathway. And it's beautifully chaotic. It's like your body is just constantly throwing out these little chemical grenades. They're super reactive, and they'll just stick to the very first thing they touch that doesn't have the right password, basically. Then you have the lectin pathway. This one's a little more sophisticated, more like a smart bomb. It has a special protein that's basically a guidance system, and it homes in on specific sugar patterns that are all over germs, but not on our own healthy cells.
It doesn't matter if it was a random grenade or one of those smart bombs that kick things off. The end game is always the same. Build the ultimate weapon. It's called the Membrane Attack Complex, or the MAC, and it's awesome. As soon as a bad guy gets tagged, it starts this chain reaction. A whole team of proteins comes together and builds this stock that literally drills into the germ's outer layer. And then, for the finishing move, more proteins rush in to form a channel, a hole right through the invader. Water rushes in, the whole thing just pops, and yeah, it's toast. Game over.
Okay, so this probably brings up a pretty important question, right? If this system is so aggressive, why aren't we just dissolving from the inside out? Well, the answer is safeguards. Our own cells are smart. They're covered in these special protective proteins. One kind is like a bomb disposal expert. It sees the attack starting and just dismantles it before it gets going. Another one literally stands in the way of that final step, blocking the proteins from forming that death channel. So our cells are basically walking around in invisible body armor all the time.
If you want to see just how powerful, how raw this system is when it's unchecked, you got to hear about this experiment. Scientists transplanted a pig organ into a baboon. The problem? The pig cells didn't have the right kind of body armor to stop the baboon's complement system. The result was immediate. The baboon's immune system just saw this massive, unprotected foreign thing and went nuts. It attacked with everything it had. In minutes, the organ was completely destroyed, just a bloody pulp. That's how fast and how absolutely devastating this system is.
Okay, so while all this chemical warfare is going on, those alarm signals are finally reaching the first cellular responders. The troops are being called in. So it's time to meet the sentinels and the soldiers of the innate immune system. These are the professional eater cells. We call them phagocytes.
All right, so there are 2 main players you need to know, and they're both amazing specialists. First up, macrophages. Think of them as the long-lived sentinels who are already on location. They're stationed in your tissues, your skin, your lungs, you name it. They're kind of the jack of all trades. Part garbage collector,
part alarm system, and when they get the signal, they turn into total killers. Then, you have the neutrophils. These are the foot soldiers, the shock troops. They are pure professional killers, just loaded with toxic chemicals, and they're on standby in your blood. Their job, and I'm not really kidding here, is to kill things and break stuff.
You know, this quote it nails what a neutrophil's life is like. They are so incredibly powerful and destructive. And not just to germs, they can do a number on our own tissues too. That they are literally born with a death sentence. No joke. They come out of the bone marrow with a timer that's set for about 5 days. This self-destruct is a critical safety feature, right? It limits the collateral damage. And that pussy CN infection, that's pretty much just a graveyard of these fallen soldiers. They did their job and sacrificed themselves.
Okay, so here's the logistical problem we have to solve. The fight is happening in your tissues. Let's go back to that splinter in your toe. But your elite soldiers, the neutrophils, are all cruising around in your bloodstream, which is like a super highway. So how in the world do they get off the highway and find the exact street address of the battle? The way the body does this is just so clever. It's this really cool 3-step process, almost like an immune system postal service. First step is roll. The alarm signals from the infection site make the inside of the nearby blood vessel get really sticky, kind of like Velcro. This snags passing neutrophils and makes them slow down and start rolling along the wall. Second step, stop. While it's rolling, the neutrophil is sniffing the wall for the chemical danger signals. When it gets the scent, bam! It throws out this superglue protein that makes it stick tight and come to a dead stop. And the last step, exit. Now it just follows that chemical trail, squeezes itself between the cells of the blood vessel wall, and boom, it's out of the bloodstream and heading right for the battle.
So here's the really crucial takeaway. None of this works in a vacuum. Not the complement proteins, not the macrophage sentinels, not the neutrophil soldiers. They don't work alone. Victory is only possible because they are all constantly talking to each other, working as a team. And together, they create a defense that is so much more powerful than any one of them could be on its own.
And this teamwork just creates this incredible cascade of activity. You've got the sentinel macrophages calling in the neutrophil soldiers. You've got the complement proteins painting targets on the invaders, which basically makes them tastier for the macrophages to eat. Even our own cells, when they're dying or damaged, release these general danger signals, we call them DAMPs, that just shout to the whole system, hey, something is really wrong over here. And if a cell gets infected with a virus, it releases a different kind of alarm, an interferon, that warns all its neighbors to basically lock their doors and put up their shields. It's all these positive feedback loops, where every action makes the next one stronger, ramping up the entire defense as the fight goes on.
But we're not done yet. There's one more really key player we have to talk about, the natural killer cell, or NK cell. And its job is different. It doesn't hunt for foreign germs. It hunts for us. Or more accurately, it hunts for our own cells that have gone bad. See, all of your healthy cells are constantly showing a little ID card that says, I'm one of you, don't kill me. NK cells are like the security guards, constantly patrolling and checking for that ID. If they find a cell that's missing its ID, which is a huge red flag that it could be infected with a virus or has turned cancerous, the NK cell takes it out. No questions asked.
You know, maybe the most elegant thing about this whole innate system is how it's all about proportion. It's designed so the punishment fits the crime. That little splinter, it gets a small, local response. No need to call in the National Guard. But a serious, major infection, that triggers a massive, system-wide alarm, mobilizing billions of neutrophils and kicking the whole network into high gear. This way, the system is super efficient. It saves energy and, just as importantly, it prevents a ton of unnecessary collateral damage.
So, to wrap this up, the innate system is our front line. It's this hardwired, incredibly fast defense against the usual suspects, the common types of germs it's seen over millions of years of evolution, and it is brutally effective. But what happens when something completely new shows up, a pathogen wearing a disguise that the innate system has never seen before and doesn't recognize? Well, for that, your body needs a different kind of army, one that can learn, one that can adapt, and one that can remember. And that is a job for an entirely different branch of your immune system. But that's a story we'll have to save for another explainer.